Bismillahirrahmanirrahim. In this part, we want to speak about the main characteristics of embedded systems. Really, we want to speak about the main parameters that that are related to embedded systems and specify for us the performance and the goodness of embedded system. Some of the main of them really are as follows. Okay, the first one is application and domain specific. What does it mean really? We want to know what is related to. As you know, each embedded system has certain functions to perform, and they are developed in such a manner to do the intended functions only. Really, they cannot be used for any other purpose. They are application specific. The embedded, for example, control units of the microwave oven toaster, for example, cannot be replaced with, for example, embedded system for control unit of any other system or any other home appliances, because the embedded control unit of this system is specifically designed to perform certain specific tasks. Then we don't have any, for example, changing or replacing of one system to other system. Then by knowing the field of application, really this system can be described. The other one is reactive and real-time. Embedded systems are in constant interaction with the real world through sensor and user-defined input devices, which are connected to the input port of the system. Any changes in the real world are captured by the sensors or input devices in real time, and the control algorithm running inside the unit reacts in a designed manner to bring the controlled output variables to the desired level. Embedded systems produce changes in output in response to the changes in the input, so they are referred as reactive systems. Real-time system operation means the timing behavior of the system should be deterministic. This means that the system should respond to requests in a known amount of time. And some of the embedded systems are reactive and some of them are real-time. This is the main difference between an example. Embedded systems. Embedded systems which are mission critical like flight control systems, anti-lock brake systems, and etc. are real-time systems. They must work in a known really amount of time. Another important parameter is the third one, operates in harsh environments. What does it mean? The design of embedded systems should take care of the operating conditions of the area where the system is going to implement. For example, if the system needs to be deployed in a high temperature zone, then all the components used in the system should be of a high temperature grade. And this is one of the examples of harsh environments. For example, a very high temperature. Also, proper, for example, shock absorption technique should be provided to systems which are going to be commissioned in places subject to high shock. The other, for example, harsh environment is high shock. Another parameter, let me to show this better, distributed. Now what about distributed for embedded systems? It means that embedded systems may be a part of a larger system. Many numbers of such distributed embedded systems form a single large embedded, for example, control unit. As you can see, by combination of different embedded systems, different small embedded systems, we can reach to a large amount of embedded system. For example, automatic vending machine. It contains a card reader, a vending unit. Each of these parts are independent embedded units, but they work together to perform the overall vending function. The other is small size and weight. About small size and weight, as we know, product as you can see, for small size and weight, product parameters such as size, weight, shape, style are important factors in choosing a product.